Have you ever found yourself just staring at a mountain of text? I'm talking about thousands of customer reviews, a decade's worth of emails, or a folder packed with research papers, and you just feel completely lost? It's a huge problem, right? We are absolutely drowning in text, but we're starving for actual insights. Well, today, we're going to pull back the curtain on two really powerful techniques, text clustering and topic modeling, that can take all that chaos and turn it into clarity. This is how you find the hidden patterns in your data.
So the real challenge for so many of us is that our most valuable information is basically trapped inside unstructured text. Just think about it. All those social media posts, support tickets, internal documents. It's a total goldmine of information. But honestly, without the right tools, it's really just noise. So the big question is, where do we even start to make sense of it all?
Okay, this image right here shows the perfect first step. Imagine you've got this gigantic, messy pile of documents, and a machine just automatically sorts them into neat little stacks based on what they're about. That, in a nutshell, is clustering. It's not reading them like you or I would, but it's smart enough to understand the meaning and group together the ones talking about similar stuff. You know, all the pet documents in one pile, sports in another, and so on. All right, so we've sorted our documents into piles. That's a huge win, but there's a really important distinction we need to make here. We've grouped the documents, sure, but we haven't actually given those groups a name yet. And this is the key difference between just grouping things and actually naming the topics. They're definitely related, but they are two very different, very important steps.
So let's get a little more specific. Text clustering is that automated process of finding the piles. The algorithm just dives right into the text, figures out the meaning, and starts grouping together documents that are talking about similar things. The key thing to remember here is that we don't tell it what the topics are ahead of time. It just discovers the natural groupings that already exist in the data. Topic modeling, on the other hand, takes things one step further. It doesn't just find the piles. It kind of peeks inside each one and goes, aha, this group here is all about food, because I keep seeing words like pasta, pizza, and restaurant. It discovers and then actually describes the abstract topics that define each of those clusters.
And this side-by-side really makes that difference crystal clear. On the left, you've got clustering, which has done the hard work of finding three distinct groups of documents. Then on the right, you see topic modeling has analyzed those groups and slapped some meaningful labels on them: pets, food, and sports. It's literally the difference between a stack of unlabeled papers and a perfectly organized filing cabinet. So how do we actually do all this? How does it work under the hood? Well, it turns out there's this really elegant and powerful three-step blueprint that's pretty much become the standard for modern text clustering. Let's walk through it. The whole process is actually surprisingly straightforward. First, we have to translate our text into a language that machines get: numbers. We call this embedding. Then, we simplify those numbers to really focus on the most important patterns. And finally, we just unleash an algorithm to find the actual clusters in that simplified data. Let's break each of those down. So step one is all about embedding. And you can think of it like this. We're giving every single document its own unique GPS coordinate in this massive meaning space. Documents that talk about similar things, like cats and dogs, get coordinates that are super close to each other, putting them in the same semantic neighborhood. This is how the machine starts to understand the relationships between all these different pieces of text. Now, this slide shows a really crucial step: dimensionality reduction. See, those GPS coordinates, those addresses in meaning space we just created, they can have hundreds or even thousands of dimensions. That's just impossible for us or even an algorithm to work with easily. So we simplify. It's kind of like taking a really complex 3D sculpture and just looking at its 2D shadow. Yeah, you lose some of the tiny details, but you get a much, much clearer view of its overall shape.
Okay, so with our simplified, low-dimensional data ready to go, we're at the final step: clustering. An algorithm just sweeps through this new meaning map and identifies the dense neighborhoods where all the documents are huddled together. This is the moment. This is when the actual groups are officially identified and our messy pile of text finally starts to have some real structure.
But wait, which algorithm should we use? Well, there are two main flavors. You've got your centroid-based methods like the classic k-means, which make you tell them exactly how many clusters to find beforehand. But in the real world, how often do we actually know that? That's where density-based methods like HDBS-CAN are so awesome. They're way more flexible, and they figure out the number of clusters all on their own.
And density-based clustering has another huge advantage. It doesn't try to force every single document into a group. It allows for outliers, those documents that are so unique they just don't really fit anywhere. And this is a total game changer for dealing with messy, real-world data. Because let's be honest, not everything fits into a neat little box.
Okay, so we have this powerful 3-step blueprint for clustering our text. Now let's see how it all comes together in a fantastic state-of-the-art framework called BurTopic, which brilliantly puts all these pieces into action. And here's the best part. You already understand the first half of how BurTopic works. It uses the exact 3-step process we just went through: a sentence transformer model to embed the documents, an algorithm called UMAP to reduce dimensionality, and HDB scan to find the clusters. It's our blueprint, live in action.
So that first pipeline gets us the groups, but how does BurTopic give those groups a name? This is where it gets really, really clever. It adds this unique second step to create those meaningful topic descriptions.
So instead of looking at one document at a time, BurTopic treats all the documents inside a single cluster as if they were one giant document. Then it just counts up how many times each word appears across that entire cluster. This gives us a much stronger signal about what the topic is really about, since we're looking at the collective vocabulary of the entire group.
But just counting words isn't quite enough, right? Because really common words like the, and, or would always end up on top. So BurTopic uses this smart weighting scheme called inverse document frequency, or IDF. It sounds complicated, but the idea is simple. It penalizes words that show up everywhere and gives a huge boost to words that are common in one cluster but are pretty rare everywhere else. These are the words that really define a topic.
And this all comes together in one powerful formula called CTF-IDF. By combining the class-based term frequency with that inverse document frequency, it generates a score for every word in every topic. The words with the highest scores are the ones that are both common inside a topic and rare outside of it. In other words, the perfect keywords to describe that cluster.
So here it is, the full picture. The BurTopic pipeline is this brilliant two-stage process. First, it uses modern embeddings and density-based clustering to find really robust, meaningful groups of documents. Then it uses that clever CTF-IDF trick to basically distill the essence of each group into a set of representative keywords. It's a powerful combination of finding the patterns and then giving them a name.
You know, what makes this whole approach so powerful isn't just that it works really well, it's how it's built. Its real strength, its secret weapon, is its modular design. That's what gives it such incredible flexibility and adaptability. The main thing to get here is that the two big steps, the clustering and the topic representation, they're completely independent of each other. This gives you amazing flexibility. You can swap out the embedding model for a newer, better one that just came out, or you could experiment with a totally different clustering algorithm. It's like building with Legos. And that adaptability means this whole pipeline can keep getting better as AI research charges ahead.
And that evolution is happening right now as we speak. Instead of just getting a list of keywords at the end, we can now feed those keywords, along with a few sample documents from the topic, directly into a large language model like GPT. We can then literally just ask the LLM to generate a short, easy-to-read label for the topic. This is a massive leap forward. It takes us from a list of words to a clean, actionable summary of what each topic is all about.
You know, for decades, we've been collecting just unbelievable amounts of text, but so much of it has been locked away, impossible to analyze at scale. But with these powerful, modular, and now AI-supercharged tools, we finally have the keys to unlock all that knowledge. So the real question is, what hidden stories, what forgotten trends, what groundbreaking insights are just sitting there waiting to be discovered in our own data?